Agora foi.
Sem fôlego oficial.
Som.
Sônia.
Sônia.
Isso é com a galera festa na Colômbia.
Sônia.
Vou esperar vocês irem embora para tirar a máscara. Good morning, everybody. Thanks for waiting. So yesterday I talked a lot. So today we're going to do more code than me talking a lot. And the idea is to check. We're just a little bit behind schedule. It's not super bad because we're going to talk about multivariate analysis tomorrow and on Tuesday. So this should be okay. But today I want you to go back to your repository and to create a new script and to go back to CESTES data. And we are going to, I didn't put in the tutorial the calculations for taxonomic diversity, but the idea is, and as I put in the tutorial, to remember the good practices. Every new script should be self-contained. So I know Sarah gave you some code to read the CESTES data. So in the fact that it's a different topic, so you go and grab that code and put it in the new script. You shouldn't have the workspace saved, so and nothing is saved in the workspace. And we're going to start at this stage. I want the community matrix, loaded. Hi, good morning. So that you have the header should look like this. And remember, this is bad because the first column is a sites column. And the same way you loaded the community matrix, you can load the traits matrix. And so as far as I know, Sarah's code already assigned some names, so we're just going to use com and traits today. And both data frames have the same problem, sites and species. Hello. So the idea is to convert these to row names. I don't know what happens here. And I will do the same. If I had two screens, I would do the same, like on my computer. I will do this in this small screen, and then we can check. But basically, the idea is that these row names that are currently numeric, they become sites, okay, in both of the columns. You can check the link today at the site. I already put the slides, and there's a tutorial link. It's a short tutorial, but we're going to go through it slow today. If you have any questions, if you have any doubts from last days or anything, you can just let me know. I don't know at which stage you will be, so just let me know here. But I will use the repo that I have. I have been, while you do this, I have been putting things in our Zotero collection, but I need to. This is my Zotero. This is our Zotero collection, and I have been putting things into a subfolder, but I will do a large cleanup to send you the references for some of the topics, because we don't have subfolders. We talk a lot about folder structure, and we don't have subfolders here. But I will create some. So, back. Oi. Do we have another mic? Because this is one is. Like, I have no idea.
Then I'll talk to the mic.
No, the other mic. So this is the dirty one. Thank you.
Is that la 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 la? In the what amongst the papers in that the diversity folder, is there one which kind of would be good for the non-ecologists to understand the diversity, measuring things and the, because I at least feel that I should read something in that direction to get
Yes,
a better grasp.
there are anything by Pavoine, for example. Anything by Pavoine, and actually lots of these papers have the mathematical, the mathematical treatment, and even the ecologist ones.
Oh, even the ones which are focused on specific packages are.
I will just clean everything, but there are some authors that are mathematicians who create indices. So when you see a new measure, it tends to have a mathematical treatment inside and some expectations of these indices.
Oh, but I meant more like being from the mathematical side, not knowing really well how all those different measures of diversity and definitions of what a community is and are done. So a more ecological minded thing that would give us base to understand.
You want more ecological?
Yeah.
Yeah, that's okay.
Because I felt that I was lacking some background when you were
Okay,
showing.
yes, because this is not an ecology course, unfortunately.
Okay.
So I have been skipping lots of things. But yes, and you have lots of treatments. I will try to find some applications that are nice about this, yes.
Okay.
Because most of the people who do diversity indexes use databases that are like Aristolochia, like mole databases, like Cestes itself. But yeah, I will. And there's ecology, like if you are interested in the ecological part, like there's lots of things inside.
No,
Yeah.
I just thought not properly read a whole book of ecology to see that, but perhaps something short, like explaining specifically this diversity part.
Yeah, that's okay. I like Pavon and Bonsal's review. This
Fine.
review.
Oh, it's a review. Okay.
It's a review. It's a biological review, but I like the way it talks about everything, about all the story of them.
I'll read that one then.
Cool. I will use. I was. Not this. Not this. So. Recent projects. Here. So, no, I did add the code for species richness and taxonomic diversity, but this is not today's thing. I will just interrupt you all the time, sorry. I created an organization in GitHub. And I will add your profiles to the same organization if you agree. So we are together and you see everybody's work. So I will do that. I just wanted you to know before. Aló, ahora sí. So David asked me about phylogenetic diversity, and I was telling him that the example of real life with cestus is a little bit too long for this class, but I will upload it because I will tell you in breakdown communications.
See if this one is working, because there may be a problem with the section.
Aló, agora voltou. Aló.
Sure. Or is it one-on-one?
Yeah, because here I could do the S here to create, it's now creating this variable because we say that binary variables treated as integral scale.
But it's the wording message is not the problem.
Yeah.
So warnings do not stop your code. Warnings are just warnings. The error.
But in this case, I tried to, and then they said that object role not
Okay. Did you take out the first column of the matrix? So is com and the traits also?
We need to take off
You have to do the same thing for the traits one. So I just didn't put the code because it's just.
Okay, got it.
But if you read the tutorial, it's like, now do this for the trait. That's okay.
Even if you take out the first
Even that?
column, it is continuously saying the warning.
The warning. Oh yes, the warning.
Just traits,
But does it create it?
because the traits doesn't have the first column.
But it does create it. Yeah, yeah. But the warning.
It is still the warning, but I don't know.
You don't have Go? You don't have the object?
No,
Yeah, the warning is. Yeah.
but the idea is, I don't know if it is.
But it is creating it. It's only giving you the warning. Yeah, yeah. The warning. Did you read the warning? Ajá. Los está tomando como binarios, eso es lo que te está contando, exacto. And if you see the name of the variable, you understand why. Because it's a set of dummy variables. Yeah. So the warning is just because you are not knowing what you are doing. So you stop and you say, what? Oh, no, but that's okay. And you continue. The warning warns you. And if you continue.
But I want to take them as if I don't want to take that as a binary,
You. Why wouldn't you, like, if it's a binary variable, there's no need to, there's no way, there's no. So. What is first column?
I think say species.
Not the first column.
Só fazer isso daqui.
It's the first thing. I'm taking out the first column. This
Oh
one.
yeah, okay.
Taking out the first column and rewriting the other.
Okay.
So it's not part of the variable. Are we okay? Perfect. 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 I put up a couple of options because in this area you have so many packages that calculate distances and you have so many packages that are related to different research groups. So this is why I am creating Gower and Gower 2, so just for you to check that it's the approaches can vary. So cluster is a base package of R, so you should be able to calculate Gower without adding anything else, installing anything else, just calling the package. And if you saw this, what did I do? Yeah. The object created by package cluster, it has a class that is slightly different than the object created by FD, but at the end the values are the same. This is the laziest way to check if it's the same, but yeah. Some of you have told me about the warning that that is being received when you execute Gaudis, because it says that it binarized some of the variables. So warnings do not stop the code, errors do stop the code. So it's just to make you aware that something is happening and some decisions were made. Hey. Excuse me? FD. Yes, he said it's FD. So. What day is it today? August 4th. Não estou te entendendo.
Você quer que eu ligue lá pra você?
Não, tudo bem. Não sei o que é. Não quero esto. I guess most of you must be already ready. So basically, Singsa package that I was showing here. Singsa packages was created by an quantitative ecology group in Rio Grande do Sul. Their authors have made the package specifically for this kind of uses. So that's why raw diversity, if you went through the help, it has specifically arguments for this kind of applications, traits and phylogeny. They have some sample data for phylogenetic distance, but I wanted to show what would be the steps for doing phylogenetic diversity analysis. And FD this is FD, created by Villéger. And if you play with the arguments here of DBF, distance-based functional diversity, you will see that you can also plot the axis, as I showed you yesterday. You had a representation, a graphical representation of the diversity into axes. So I don't want to see this help. I want to see this help in the R session. Wait. I don't have my session anymore here. Here. This should be here. Wait. These two are kidding me. Because it's distance-based. So far you don't know the names of the species in CESTES data, but you have one of the objects is the species list. If you can gather it from your workspace, it's one of the lists, it's one of the files. Yes, exactly. Yes, it's the fourth, it's species list. I am reading here the date, the table, and it does not have any information about the families that the species belong to. So I will have to gather the families somewhere. So a couple of days ago, we saw some of the taxonomic databases tools. So we'll have to take this vector of names and pass it through taxize to check from which species do they belong. This is not my favorite kind of database because I would like families to be there already, yeah. So what we're going to do is we're going to use library taxize to check which is the hierarchical position of each of these names in the tree. Okay. And the function to gather the rest of the classification is classification itself. So we are going to use classification for this vector. If you go to the help of the function, it will show you that it needs some database to be present in the parameters. So I did it without a database, and it said, no, error, you have to put a database. So we're going to use IE, not Tropicus, but this is NCBI, like the National Science NCBI as a database. And what it will do is just take the whole hierarchical information for each of the species and let you know if they found their name. Oi. Yes, for the NCBI. So if you explore this object, you will see it looks a lot like a list. I don't know if you talked about lists before, but basically lists are elements that are more complex than vectors and than data frames, but they are also more flexible.
Andrea, can you remind me the package name for the object classification?
It's tag size, line 23. Yes. So classification looks a lot like a list because every name, under every name, it created a data frame. So it's a list of data frames. And this is the kind of object that R does very neatly. It can nest data structures inside very, very easy. So if I see the length of the classification list, it has the 56. It has the 56 elements that we put inside. It's the 56 names. I will explore just the first one. Just to understand how the data is. And there are two ways to index makes a list. Either you use the $sign, and it has names. So every name is will give you back a data frame. Or you can use the double bracket with 1. So the only difference here is that it takes away the name. You're already telling the name. No, it returns the same data frame with name, rank, and ID. And if you see, for every element of this list, it's the line, you have a line that has the family. And we want the family because what we want to do is to match the name of the family to a large angiosperm tree. So this is why this is way more work than functional part. Okay, so how do we extract the family element from any one of these data frames? We could use just filter and filter by family, something like that. But for every element of the list. We are not going to solve these kind of problems because I don't know if you saw that it didn't find some species. That happens a lot. Like you have species that are sampled in the field that you have a name that the databases don't find. So you have to take the tour to check what you're going to do with that name. We are just going to ignore this. So for example, one of the elements of this list is NA. I don't know if it's the third. No, the fourth. So for species number 4, it didn't find anything. And this happened 5 times or 6 times in this data frame, in this data set. So I want to filter the family for every element and have a vector of families. That's my current goal. Okay, so we are going to do this because it's a list. We're going to do this for the first element of the list, and then we repeat it along the list. And there are many ways to do this in R, so it's okay. So I will just use the first element of the list. And I will use dplyr today. I could use brackets, but I will just use select and filter options. And I will use the pipe. I know that some of you are already familiar with the pipe. I know that Sarah didn't talk a lot about this kind of syntax, but this is something that you find in the internet. Do you want me to put this a little bit larger? So, classification data. First element. And I will just filter. It's rank. Filter rank equal family.
Sorry, can we turn off these lights here, maybe?
Of course. I don't know. I'm just.
See. Thank you.
My neck is killing me here.
I think it's the other. Yeah.
I think it's. Yeah. Okay. So what I'm doing is, and every time I do a function, I start with the simplest element, and in this case, is the first element of the list. So what I am doing is filtering for the rank of the family, and I would like to have a reishi as a vector. Okay. You can, of course. It's 2 equals. I am so sorry. It's because I am just very tacky and I use a font with ligatures. That's why my little arrows are but this shouldn't be the thing. This should be You're so right, I'm sorry. No, that's okay. I don't know if now everything went. Better. Yes, it's 2 equals because we're filtering. And maybe I just want to select the name. So at the end, I will have just one element. One thing that happens with dplyr is that it always returns an object that is a table, that is like a data frame. It will never return you only a vector, a character, a vector of a character. If you want only the character, you have to use function pool. I will just use this to show you. So this returns a table. I will just call it table example. I cannot do this. It's a data frame. Are you following me more or less? That's okay? So, okay.
Está diciendo que mi goal y mi count tienen como tamaños diferentes y no entiendo por qué.
No debería.
No, no debería.
Puede ser porque no quitaste una de las columnas de trains.
No, pero mira que sí.
Dim, pon dim. Y pon dim de... Alguna cosa pasó que se te
sí.
quedó uno
¿Y
más.
por qué?
No sé si es que no la quitaste.
Todo mal. Bueno, voy a mirar. Listo. Y te iba a preguntar por qué tengo... Aunque no sé si es por eso. Acá no debería aparecer, es cuando miro.
¿Qué cosa?
No está el SP1 en esta columna. Es por eso.
Es por eso.
Pero
No,
sí
no,
debería
tal vez
estar.
dice Melanitis está bien, porque igual no tiene la diagonal.
Sí, pero igual no entiendo por qué no aparece.
Es una manera de printear, en realidad.
Ah, ok.
Está printeando seguramente, pero no sé si es. some of you are still in the Gower part and the functional diversity part, and I just stopped here to show you how you would extract the family from the first element of a list of names. I don't want to run, but I don't want people to be waiting, so I don't know if I go ahead and is it okay? Or if people who are already here can find a way to obtain a vector of families. Like we want this, but we want a vector of families or a vector, maybe even if it's a data frame, if you want to try ways of extracting families from this list. Okay? While we are in the same page.
So here's my problem. I don't. So my thing is not managing to catch to compile one of the not compile, just find one of the dependencies for the text size package. And so I want to know what the classification function does. So maybe I can try to implement it.
Oh yes, it just goes to the database and extracts. It communicates with the API,
Okay,
and
so
it takes all the
maybe
hierarchical information.
okay, so I
So
have
there
to
are
figure out the API
other
of the
ways to do
NCBI.
this? No, yes, this is something that is not necessarily something. But text size, is it the version that you're having, maybe?
I don't know.
Or
I
maybe
had
when
to
you
restart
started-
my whole repo because I didn't have RStudio installed and stuff like that. So I had to refactor everything at some
But
point.
what? You have R3.6, so maybe that's the problem, that you have an old version. Yes. R is in 4.2. 3.6 is kind of old, but that's okay, that's okay. It's really, the problem is that probably CRAN is taking things, and the newer versions of R
How do I
find
check?
all the
Oh, it's here.
Yes. That's how I knew
How do I
it will make you reinstall packages, so depending on what you're working locally. Do you have any work that's okay?
I don't know anything about it. It's my first time.
So maybe are you using this is Mac, but I don't know why it was a normal installation. You have a normal installation. So I don't know why it is installed with 3.6. It should have installed like the 4.2, something like that. Is it an old
I might have.
operating system?
Yes, it is a bit old. I think.
I have Mojave here. It's not super recent. Okay, you're more recent than I am. So, okay, yeah. So maybe it's the version. It's probably the version, or maybe
Okay, I'll
install
try to
packages.
reinstall R.
Dependencies equal to something like that to see if it pulls the dependencies better. I will just. Oi. Who is? thought somebody was calling me. I swear. I thought somebody was calling me. So I just pushed to the test intro, what I'm doing right now with classification. But in case you want to pull it from there, but it will be there. And it's only the beginning, of course. We have this, and we want to add a frame of the families. Can I try? Do you have any ideas? Did you try to do it somehow? I would say I would think about a for loop. The most basic would be execute a for loop. I know the apply families exist, and people do like a lot the apply families, but I think they're a little bit. Sometimes it's too complex. I will do it with a for loop, and we execute. So, to execute a for loop and to extract the elements of a list to a for loop, you have to have an object that obtains the vectors. So I will create an empty list. I don't care about the length right now. This is the syntax for a for loop. I am just going to do here the loop, and what I am going to do is for every element in the for loop, I will fill the element of the list that I am created. It is empty, and I will here extract the family. So here I should have the function that extracts the family, or some code to extract the family. So this is the syntax. But how do we extract the family? So if I know this works, I could create a tiny function. And then I put here the tiny function. Let me know if it's clear for you. We will try to create a function here to extract the family. So it's not code, but something that is more generalizable. So we can create a function to extract the families. And since this is not going to be fancy code, since it's not going to be something that goes to a package, I can do a very quick function that not necessarily goes into fame. And I will just copy this code. I know that for the first element, this code worked, so I will just copy it. I don't need anything more complex than this for now. So literally, I will copy it here. But inside the scope of the function, the first element that receives the function is x. Okay. So this is x. It's going to be the first argument of the function. And this is x. For every x, I will filter the rank, and I will select the name. This is basically what the function is going to be. We will have NAs, and the NAs are going to be not nice inside the function. I would have to check if x is not an A, but I can also do it. Since we are here in the exercise, I can do the check for NAs in the loop, in the first loop. So the function can be easy, or the for can be easy. In professional settings for production, you have to do these kind of things, and to check the classes and to check the lengths. We can do it here if you want to. So if x is not an A, basically, so how do you say it's not an A? It's not if x is not NA, I can create here a result, and I just say like return y. And this should work, I hope. The other alternative, I don't think it's not always necessarily, like what if it's NA? Okay, so you don't need this. I will just put this into brackets because I have a multi-line setting. So if X is not NA, please do the filtering. And I will close it here. This looks like I don't know if it's gonna work, but this is something that you would do in real life. So I'm just checking the space and the code styling, and I'm just going to execute it to check if the function works. So what happens when I execute? It's created in the workspace. So we have now a function that is called extract families. It's a function. And it did not return any call. So syntactically, it's correct. And for those of you who work in Python, remember that we don't have problems with indentation, but with keys, with. And how do I know if it works? I would have to say extract family to execute extract family with the first element of the data frame. So the exact code that I executed here, I want to execute it to the first element. So I will take the first element and I will check if the function works. It did not like me because classification data is a data frame, so is NA does not work in this context. Okay, how do I deal with this? So if it's NA, it cannot return Y because Y is not found. So what did I do? I executed the function I created into an object that I know is an A. So I hope it works. And what did it tell me? It said, A, object Y was not found because the Y was after I close this, after I create Y. So I just put this line inside the brackets, and now when it's an A, it does not work. It does work, but when it's not an A, it's not liking that I am creating a data frame. So I have to check. It's a table, yes, but also. If it exists, if it's not an A, the object exists. Well, one lazy way would be to put any. If any of X is NA, I will take it. And the other thing that happens is that dimension of the non-NA objects is non-null. So dim, just let me check, like classification. The dimension has length 2, but the dimension of an NA object is null. So if I say if the dimension of X is not null, if the dimension of X is not null, then do the calculation, because it's the way to know if you have something or not. This should work. This should work. Okay, now it works. So it's like a way to quickly know when you have an object or not. Where did I what? Here?
Oh no, it just wasn't from the.
So we started with a is an A, and we decided to go for a dim because we had a data frame, and data frames are not, they do not respond to is an A. So now we have a function, and now we have something that works with non-NA and with NA. It won't do anything, okay? And now that function, we're going to use it in the for loop. If there's something that I need to stop and come back here, I am here. I will just make that commit, so you have the code. And every time I do commit with the graphic interface, I think of Sarah saying that you should use the terminal. I'm just going to push here. This is our way to communicate. We have git commit, a commit via git commit communication. I don't know if she told you, we had a repo that we only had the git, the informative git commit messages, were only lyrics from a singer. We took like songs by her, and it was like this. And it made sense, it was so fun. We're just silly. But I added the function just for you if you want to go and copy it, or if you want to type it, just to see. And this is the kind of work that you have to do, like during the work. It should exist. I was looking for it, like, how come I don't have a function that gives me a family? No. So it's like, okay, sometimes R does everything, and sometimes it does not do like the basic thing, like I want the family, just give me a family. But okay, I will extract family inside the for loop that was waiting for us. Okay, so we have families, and this is for the people who like Python and who like to append things to vectors. This is our way to do these kind of things in R. Is that we grow empty lists and we fill each element. So basically right now, families is empty. I does not have a value because it's not even part of I haven't executed anything. And I will recur between 1 and the length of the object and execute this function. So what I will do is extract the family of classification data, but instead of a numerical index, I put the I here. So it's not beautiful code, but it will do the trick. There are way more beautiful ways to do this. So if you allow me, I will try to run it, and we will see if it works. And it works, because it didn't say anything. And if you see right now what happens with families, it's a vector, it's another list, because that's what we do, and it has the families. And it has DNAs, because it had DNA. It has 56 elements, which is good, so we can just add it to this. So what if I don't like the fact that it's a list. It's the way I think a lot. Sometimes what I do is try to create lists. Okay, not nice. So maybe we want a vector. So maybe we want a vector instead of a list. So vector, an empty vector, and instead of filling a list with elements, since it's only one, we just index the vector. And families, it's still a list. Why? Because extract family is returning a complicated object. It's complicated, so it's like, oh, you want a vector of data frames? You have a list. So we should just, instead of select the name, what I was telling you, pool should do the trick. Pool, it returns a data frame. If you say pool, I will just, this is why I was doing this example. If you pool, it will give you only the object. So extract family, it will give you only the vector without it being a data frame. And now we can have a vector that is filled. This is life in the tropics. So if it has length 0, okay. So that's okay. If, I will just do this. Family, and if length of family, length is equal to 0, do nothing. No, it's more than 0. Then families, the first element, the element is F. Yes? Okay. So now families should be a vector of characters with an ace. So, and it has an ace. Why? Because the function itself didn't found some names at the beginning, the API. Classification from tag size didn't find the whole names. So we needed to treat DNAs without losing the length and acknowledging that at this stage of the data, of the Cestus data, that data frame does not understand this name. If it was your thesis, you would go after those names and you would check what is the name and how you do it, or you just Google the family and the life goes on. I just wanted to show you how is the process of creating a function when you have a problem with this. So this works. And the next step would be something that is something that David was asking. Now we have the families for the species, and I don't know if you have ever worked with phylogenetic data that is pre-built. So I will just show you Magallon. Some people do this beautiful work in life. I don't know how it works for, wait, this is not what I was expecting. Some people who are evolutionary biologists resolve meta-calibrated trees, large trees. So we have in biology classifications, and we have different classifications for animals and plants, and meta-calibrated time trees are there as supplementary material of some people's work. And this meta-calibrated time tree created by Susana Magallon, she's at the UNAM in Mexico, looks like this. I don't have it here. It looks like this. It's a raw. It's not here because it's the other repo. Looks like this. Phylogenetic trees in computation analysis are basically text files that have parentheses and that join the clades. The closest clades are inside closest parentheses, and the nodes are dated. So this is how a tree looks in a text file, and there are two formats: Newick and another one that is more complex. It has inside a Newick tree, so R leads well with Newick. And we have some packages that will read these trees. So if you see here, everything that is ending by AG, most of you, I don't know if most of you are biologists, I never knew. What we need to do is to find in the list, in the vector of families, what we have, to find those nodes, to create a tiny tree of our community. So we have 56 species. We don't need all the nodes, all the terminal nodes. We will have to purge it. So for example, Marcilici, all the ferns are going to go out because we don't have fern families. So how does it work? But I will stop soon. You have a series of packages like ape and picante. Ape, analysis of phylogenetics and evolution. So Emmanuel Pajadi has a book about analysis of phylogenetical data in R, and it has a companion package. And one of the functions is read Newick. So one of the functions of a package is Nexus is the other one. Nexus. The difference between Nexus and Newick is tiny, and it's ape. Ape reads Nexus, and PhyTools, which is maintained by Liam Revell. He's another very famous biologist, evolutionary biologist. He has read Newick. Okay. And we would read the large tree with this function. I will just use the other. This is not the one here. PhyTools, read Wick, read tree. So I will add this large tree to the repository, the diversity matrix. To data. And if you plot it, it will take forever because it has all the angiosperms. And sometimes it does crash the thing. But what I was meaning is that it's a longer workflow, because you have sometimes to curate your data and check the families and go, plot, APG, please. You can talk.
You can modify the Newick file inside R. I don't know, if you want to delete, erase.
Yes, you can drop tree tips, you can edit everything. It is not beautiful at visualization, but you can, if you have something. If you have a trait that appears in some groups and not, and you have a vector of the branches, and where does the trait appear, you can plot it here. You can say like please plot the tips with the symbol and color that I want inside this. You can drop some tips. You can prune the tree. If you, yes, you can do like lots of.
There are libraries that help for visualization.
I don't hear it, but also, where's the mic? It's trying to plot the labels because it's a lot.
There is libraries that help us do the visualization, like are really fancy or I don't know, on libraries that we can use to plot this in a beautiful way.
Plot the trees
Yes,
in beautiful
yes.
ways. I know GG3 exists. I have never used it. When I work with phylogenetic diversity, I didn't even use ggplot at the time.
Where the people in the
GG3.
GG3 use?
GG3, yes, GG3, and GG3 works well with ggplot functions.
In the articles they use R to do this?
Yes, inside, yes,
Okay.
absolutely. If you need something that is fancier,
Yes.
maybe you will want to go out, because we are not super, like, you have to use R, but
No, just
depending
to
on the
know,
visualization that you want, GG3 should work
in Python
well.
is kind of
GG3,
difficult to
yes.
visualize the...
Yes, what we do all the time is like plot, because Bayes knows how to plot. But if you want visualization that is beautiful, you go via the GG3 part. I will stop here. Like, the next step would be to prune this tree and to calculate the phylogenetic distance for the community. So not, like, it's a longer workflow. I just wanted to show you, like, how do people work when they do this kind of work. I will upload the tree, and I will upload the next part of this workflow. And tomorrow we talk about multivariate analysis. Okay? Questions? Anything? I know the last part. No, yeah, that's okay. Lunch. I will just do this right now.
Are you doing the commit on
I am.
Sarah's repo?
Yes, the same.
Okay.
I am using the same repo that Sarah set up for you, so the Cestes part and everything. It should have the previous R files that you had, okay? And yes, we will do a commit with. Is it master or main? Main. Cool.
Solamente una pregunta sobre el
Claro que
código.
sí.
Es que, bueno, yo me perdí. Lo que hice fue copiar el código que
Sí,
estaba
sí, dale.
en este. Y después me perdí. O sea, teníamos que hacer esto